Alright, so today we are starting conic sections. Conic sections, literally, sections from a cone. Okay, so we've got these two cones, they're inverted, and you can see the conic sections are created when we take a plane and we cut through the cone in different ways. So if this plane right here, when we cut through perpendicular to the base, parallel to the base, we get a circle because it'll have the same shape as the base, and the cone's base is a circle. If we tilt it a little bit, we end up with an ellipse where the circle is stretched in one direction or another. Okay? If we increase that angle and it cuts through the base of the shape, that's where we get the shape of our parabola. Okay? Now, if the plane cuts perpendicular to the base, we'll actually cut through part of the bottom cone and part of the top cone and hence get the hyperbola. So these are the four conic sections we're going to be dealing with. Okay? Now today we're just going to be going over circles because they're the easiest ones just to get your feet wet. But tomorrow we'll start with parabolas and then we'll move on to ellipses and hyperbolas. But they all come from this idea of cutting through a cone with a plane. Okay? So let's start with the circle. Circle being one of the easiest ones. Okay? Circles, you will see them a lot. Okay? Mainly, we actually see them a lot in nature. Okay? Like the Earth is a three-dimensional circle. We call it a sphere. It is not flat, as many people think. Okay? So circles. Now, the equation of a circle is really, really simple. Okay? The standard form of circle with a center at 0, 0, or the origin, and a radius of r is x squared plus y squared equals r squared. Okay? We've seen this equation already when we dealt with the unit circle, because the unit circle equation is x squared plus y squared equals 1. Because the unit circle has a radius of 1, so hence x squared plus y squared equals 1. Now, this equation is really simple to graph. Here's my circle equation. That means my center is at 0, 0, and I have a radius of 2, because 4 is my r squared. So that means r is 2. And drawing the circle is really simple. You start from the origin, or the center, and then you go out in two directions into the radius. So, in other words, you start at the center, you go out this way 2, this way 2, this way 2, this way 2, and then you draw your circle. Really, really simple. Okay? This is the equation. Now, if the circle's center is not at the origin, HK should look familiar to you guys. H is our transformation, our horizontal shift. K is our vertical shift from transformations. So the center of the circle is at HK, which means it's been shifted left or right and or up and down. But it still has a radius of r. This is my equation. And just like we were just saying, x is my horizontal shift, or h is my horizontal shift, which goes with x, and k is my vertical shift, so it goes with y. So this represents a circle that's been shifted left or right or up and down. And then our example looks something like this. This is my equation. So again, this is h, this is k. So my center, therefore, is at 3, 3. And a radius is still 2, which means it's the same circle, except it's been shifted to the right 3 and up 3. So it just moved my center to here. You still have your radius of 2 around, and that's how you draw your circle. Okay? Really the easiest of our conic sections. Okay? Now, let's go back to geometry a little bit. Like I said we were going to, and we'll talk about the distance formula. Okay? In geometry, we learned how to find the distance between 2 points. Okay, this is our distance equation. Now, they came up with the distance equation, which is basically nothing more than Pythagorean theorem. So if we think about this, as a triangle, this point here, this distance from here to here is 4. This distance from here to here, 1, 2, 3, 4, 5, 6, 7, 8, is 8. Okay? And this basically represents C equals the square root of a squared plus b squared. This is side B right here. This is side A. That means that if you know this distance and you know this distance, you can do that. Or if we're talking about the distance in the x direction, from 3 to 4, sorry, from 3 to 7, that distance is 4. So this side is 4. And that's what this represents. 7 minus 3, which is 4. And the y distance is -2 to 6, which ends up being -2 minus 6, which is -8, and then you square it and you get a positive number. But basically all we're doing is dealing with Pythagorean theorem. So you could either use the distance equation or you could use the Pythagorean theorem. Also, this right here, x2 minus x1, that's also what we know as delta x, change in x. And this right here is change in y, delta y, which also represents slope. The slope between these 2 points, the rise is 8 and the run is 4. This is my change in y, my delta y. So you can see how this all kind of connects together with some of the stuff that we know. But if we were using straight distance formula, we just plug in the points, we'd write the distance formula, plug in the values, rewrite it, and then that would be our answer. Okay? But you could either use a distance formula, or like I said, you could think of it just like straight Pythagorean theorem, which is, I think, a little bit easier. Pythagorean theorem is a little easier. Okay? So the distance formula is something we're going to be using. Also, midpoint is something else that we need to be using. Okay? The midpoint between 2 points, point M, or midpoint, between A and B is this equation, which is basically nothing more than average. This equation right here is the average, because how do you find an average? You add up the numbers, divide by the number of numbers there are. Well, you get 2 here divided by 2. So this is the average between my x values, and this is the average between my y values, or what we call the mean, which is also means average. Okay? So the midpoint formula is nothing more than just averaging your x's or averaging your y's to find the point in the middle. Okay? And we'll see if my next slide works because it's got embedded parts. Nope, it's not going to work. I tried. Your code for today is going to be PR3C4L. So for my students that need the code for today's lesson, it is PR3C4L. And that are circles. Okay? So the hardest part about circles is just trying to figure out the information that they've given you and what equation to use.